Sure.
Perfect. Right, so guys, I don't know if you've written up already. I'll just give you like 2 seconds or so, and then we will move to the next one. The next one will be exercise 3, number 1. Exercise 3, number 2, page 200. Exercise 3, number 2, page 200. Right, ABCD is a poem. ABCD is a poem. And DC, this is this one here, DC is equal to BN. So DC equals BN. Guys, am I going too fast? Just let me know. Anybody?
So I think just please slow down a little bit.
Slow down a bit. Okay. Slow down a bit. Okay, cool.
Thank
Right.
you, sir.
Okay. Right. So ABCD is a poem. That's this one here. ABCD. This shape here, right? So this is our poem. But they're also telling us that DM, that's this distance, DM, or MD, right? DM is equal to PB. So let's mark all of that on the diagram, right? So this one equals that one. So we're just talking about the piece, right? Just the piece. Where am I getting this information from? From here. So DM is equal to BP. Right, we're good there. DC is equal to BN. So DC is equal to BN. All right. So class, also this is based on theorem 2. So if you're just looking at it, you can already see that this is a poem. They want us to prove that APNM is a poem. APNM is a poem. Now they already told us that ABCD is a poem. So if ABCD is a poem, who can tell me if this will BM be equal to MD? What you think? What you think, guys? If, because now notice they told us ABCD is a poem. So ABCD is a poem. Will BM be equal to MD? Anybody? Will it be equal?
Yes, it would.
It would, because it's the diagonals of a palm bisect each other. You see? Perfect, Lutzen. So the diagonals of a palm bisect each other. So this one would be equal to that one. Now, class, you have to ask yourself, you see, all you have to do is look at the diagram. Why did they draw ABCD in such a way that it connects with the diagonal of the shape that they want you to prove is a palm? You see, this is how you have to think. So, notice that CD, AB will be directly equal with CD. Do you agree? You understand why? Because
Yes.
ABCD is a palm, and the opposite sides of a palm are equal. So therefore, AB is equal to CD. Opposite sides of a palm are equal. But look at this. Isn't this a palm? This is a palm. Notice they told us that. So you see, the whole focus is on this shape. You with me? This is a diagonal. This piece is also a diagonal with this piece. You see, the diagonals of a palm bisect each other. So notice, from there to there is the same, because this is a palm. This side equals to that side because this is a palm. So class, look at the diagram there now. Check it out. Don't you have diagonals bisecting each other? Therefore, that is a palm. Why is it a palm? Because this piece is equal to that piece equals that piece there. You see, maths is easy. So all we have to do, guys, with this geometry, with all the examples in the book. Notice when I first did the first example, I did it line at a time, right? Trying to, let you document it as we're going. But notice now I've changed. What am I doing? I'm taking all the information it gave me and I'm marking it as I read it. Now when I look at the diagram, there's the answer hitting me in the face. The diagonals bisect each other without writing anything on the side. You see it? So what you do when you're sitting with your book, look at the diagrams and say, listen, they gave me this. Let me put all my information on this palm. Mark everything. This one will equal to that one. This piece will be that one. Then you look, then when you mark up all the other information, the answer is staring at you in the face because there's that piece and that piece now looking identical to each other. Can you see it? Right. Now we're going to go back and write all this stuff down. Right, so the first thing we'd like to say is that DF is equal to, which example am I busy with now? I'm busy with the last one, sorry. AB equals CD. So AB equals CD. AB equals CD. What's our reason there? Opposite sides of a palm. Right, so AB equals to CD, opposite sides of a palm. Right, we can't really use given because you see they tell us it's a palm, right? Now because I marked it on the diagram, it looks like it could be given, so it's a bit dangerous, right? So what you'd rather do, if you're going to mark it on the diagram and it wasn't told to you that these two sides were equal, I normally tell a person to circle it, to say, well, these marks were not really given in the information, but we're extracting that from the palm information. Right? So opposite sides of a palm. CD, right, is equal to BN. So CD equals, did I make a mistake there in the writing now? Oh yeah, sorry, yes, BN over here. I couldn't see it. So CD is equal to BN. Given. So this one's given, right guys? CD equals BN. So we got that line equal to that line, right? So now we have this one equal to that one. So therefore, AB is equal to BN. So AB equals BN. Let me just explain it one more time. So we said that AB is equal to CD, opposite sides of a palm, because they tell us it's a palm. BN is equal to CD, that was given here, right? There's it there. Therefore, this one equals that one. AB is equal to BN. Right, the next one, we are trying to prove that the diagonals of this shape bisect each other. So BM is equal to MD. Diagonals of a palm bisect each other. BM is equal to MD. The diagonals of a palm bisect each other, and that's palm ABCD. Now they told us that MD is equal to BP given. So MD is equal to BP given. So BP, MD are equal to each other given. Therefore, BM is equal to BP. Therefore, APNM is a palm. The diagonals bisect each other. So what do we mean by diagonals bisect each other? We mean that this whole distance is cutting off over there. This whole distance is cutting off. So this piece equals that piece, and that piece equals to that piece. So once you can prove that those pieces equal each other, then it's a palm. Okay, I hope that one made sense. The next one, class, will be the same activity, exercise 3, I think it was, but we're doing number 3 next. Number 3 on page 200. Right, our information here is PQRS is a palm. PQRS is a palm. PQRS is a palm. PR and QS intersect at T. So PR and QS intersect at T. Notice they're not saying they bisect each other. They're saying they intersect. Okay? QT is equal to RM, sorry. QT equals RM. So that's a given, okay? So this one we can mark on the diagram. QT is equal to RM. That's a given, so we can mark it. SM is equal to PT. SM is SM here, equals PT. PT is there. Right. So they want us to prove that R, T, S, M is a palm. So notice these drawings, class, they always link one palm to another palm. So that's what makes it so simple. So if your eyes can see how they link one palm to another palm, why do they tell us that P, Q, R, S is a palm? Because they want us to have a common side over here. Can you see it? So notice that they gave us that this side is equal to this side. So your brain has to say, well, if this is a palm, then this one is equal to that one, the diagonals of a palm. You see? Then obviously then this piece will now be equal to that piece, because this one is this one, and they told you that this one is this one, so this one and this one is now equal. Does that make sense? Does, right?
Yes, it does.
It does. Perfect. Now, notice how they're doing the same thing on this side. They gave you that this one equals this one. They gave you. So you have to ask yourself, why did they give you that? They also told you that this is a palm, right? This is a palm. This is a diagonal. So the diagonals of a palm bisect each other. So that means that this piece is equal to that piece. The diagonals of a palm bisect. But they told you this one is that one. So that means this one must be this one. So let's think about it. You will now have this one equal to that one. You will now have this one equal to this one. So therefore that thing's a palm. Opposite sides of a palm are equal. You see, it's very easy. Right, so notice with all these drawings, they will always link one shape or one thing into the other one because they need a common thing to join them together. That's practically what you're doing over and over and over. So if you understand that, you're away. Right, so let's look at it. We're busy with example 3. The first statement there will be SM is equal to PT. So SM is equal to PT given, because that was our given information. So SM is equal to PT given. PT is equal to TR. The diagonals of a palm of PQRS bisect each other. SM is equal to TR. We know that, SM is now equal to TR. Okay, that's our conclusion. SM is equal to TR. QT is equal to RM. So QT is equal to RM given. QT is equal to TS, diagonals of palm PQRS. Okay, guys, are you coping there?
Yes, sir.
Okay, not too fast.
No,
Kinda,
sir, you're
Fine.
fine now.
kinda. All right, good. It's hard to say, it's not like when you're sitting in front of the children, you can at least see their eyes and their hands if they're still writing. Okay, so it's a bit weird for me, but let's carry on. Therefore, Rm is equal to Ts. So Rm is equal to Ts. So now we have that one side equal, we have the other side equal. Therefore, RTSM is a palm, opposite sides equal. Okay, so normally I like to write two pairs. Two pairs. I don't know how come I left it out. Two pairs of opposite sides equal. Two pairs of opposite sides equal. Okay, the next one here is going to be lesson 7 and 8. So lesson 7 and 8 PDF will be next. That will be theorem 3, based on theorem 3. But yet sometimes not all examples will be based on theorem 3. This is how this textbook is, because I didn't find that these examples were linked to theorem 3, but some of them can be. But I didn't find the ones that we did linked to theorem 3. Or at least maybe one, just one of them were. Right, so lesson 7 and 8 is next. PDF, exercise 4, number 1, page 201. Okay, so they're telling you here, triangle ABD. So the A is not too clear in the diagram. I'm just going to draw it in there. Here's the A. The ABD. And BCD. So they're saying this triangle and this triangle are both isosceles triangles. Okay? So they're telling you that C is 75. So C is 75. You can write it in. C is 75. And A, so there's that notation I was talking about, right? ADB is 30. So ADB is 30. So they could have just said D2 is 30, but they didn't, right? So they're using the other notation. So this is 30 here. Right. So class, if this is an isosceles, they say we are required to prove that ABCD is a palm. That's the goal, to prove that it's a palm. So if this is isosceles 75, right, now we can see that this is a very long line, right? Very long. This one's very long. They're probably not the same size in this drawing, but just by using common reasoning, this one's very long, very long. So these must be the two sides that are actually equal to each other, right? These two sides are equal of this isosceles triangle, right? So that means D1 we can easily work out. Equal angles, opposite equal sides. So these two will be the same. In this triangle, if this is the small acute angle, and these are also acute but closer to 90 degrees, then if this is an isosceles triangle, then surely this angle and this angle will be equal, right? How are we going to find the value of these? Quite simple. 180 minus the 30. The balance, the answer, divided by 2 will give us the value of these two angles. From there, you practically got the solution in your hands, okay? So this is a very easy example. Right, let's start. BC is equal to BD. So BC is equal to BD. BC equals BD. Remember that it was an isosceles triangle. So we're going to say triangle BCD is an isosceles triangle. That will be our first statement. Then we'll say AD is equal to BD. So AD is equal to BD. What will be our story there? Same thing. ABD is an isosceles triangle. So this one, BD, is equal to AD because it was given. that it's an isosceles. So class, can you really see this thing is looking like an isosceles triangle? Alright. So yes, true, this one is based on Theorem 3. Sorry, I made a mistake here saying that not all the examples. This one is based on Theorem 3 because Theorem 3 is one pair of opposite sides both equal and parallel. One pair of opposite sides both equal and parallel. That's what Theorem 3 is about. So class, notice already just by looking at what we proved, you can already see that BC is equal to AD. So if you can prove that this one is parallel to this, then it's a palm because you already have that this is equal to that. So don't forget, as soon as you have one pair of sides both equal and parallel, it will be a palm, definitely. Right, so let's carry on. So our next statement, we'll say BC is equal to AD. BC is equal to AD. Right, but we're also noticing that that is now one pair of opposite sides equal, right? We know that in our head. Right, so this angle, D1, is 75. You know why it's 75? Because it's equal angles, opposite, equal sides, okay? Equal angles, opposite, equal sides. So angle C is 75, given. D1 is 75, angles opposite equal sides, angles opposite equal sides. Now we can find B1, you agree class? We can find B1 very easily using the interior angles of a triangle. So using interior angles of a triangle, we can say 180 subtract 75, that will give me that angle, no problem. Right, so 180 minus 275s will give us 30. So 2 times 75 is 150, 180 minus 150 is 30. Our reason there is the sum of interior angles of a triangle. The sum of interior angles of a triangle add up to 180 degrees. So we know that D2 is 30, which they told us. Remember D2 was 30, they told us here. D2 is 30, so D2 is 30. Now class, notice something. How much did you work this angle out to be? It was also 30. Now if this angle is 30, and this angle is 30, are those alternate angles? Yes.
Yes.
Yes. So D2 is 30, alternate angles, ABD equals D2 equals 30, right? So I'm just trying to show you that that's how you write it. Two options of writing it, right? Because if you say D2 is 30, a person might wonder where you got this from. You got it from there, you see? So that's why I included it over here. And these are definitely alternate angles. So if the alternate angles are equal, so B1 is equal to D2. If the alternate angles are equal, what you can tell me about BC and AD? Therefore, BC and AD must be parallel. Alright, must be parallel. So now we have just proved that because this is 30 and that is 30, alternate angles, therefore BC is parallel to AD. You see, we now have our one pair of opposite sides, both equal and parallel. So class, look at here, for example. It's a pity I don't have a ruler. Okay, let me just use my idea. Right, so let's say, for example, I think I did explain this the other day, I'm not too sure. Let's say both these are 5 centimeters, right? 5 centimeters, 5 centimeters. So they have the same size, and let's say it's parallel as well. They're the lines in my book, for example. That's a palm. You see, both equal because they're both 5 centimeters, both parallel. So all I do is close it up here, you see? It's definitely a palm. It'll be parallel both sides. Okay, is that one good? So therefore, ABCD is a palm, one pair of opposite sides, both equal and parallel.